So greetings to one and all, and thank you so much for visiting my video. So today we're going to talk about modulation techniques in digital TV broadcasting. So this comes under the domain of digital communication. So we'll talk about what's modulation, what's digital broadcasting, and so on. So first, introduction. Digital TV broadcasting is the transmission of television signals using digital rather than analog formats. It offers several advantages, including improved picture and sound quality, more efficient use of broadcast spectrum, and the ability to transmit multiple channels simultaneously through a single frequency. Key features are high definition and ultra high definition UHD, multi-channel audio, interactivity, data services, and transition from analog. So basically, the DTH or the new generation of televisions or digital displays, they use digital signals to transmit the frequencies, and while on receiving these signals, we are able to view the particular channel of that particular frequency. So every channel might have a particular frequency. So on the basis of our input, we get the digital frequency, which is received by the antenna or whatever the mode of receiver we have on the digital um, broadcasting medium. And then this frequency is then received, and we get to view the our channel. So modulation. In simple terms, modulation is the process of carrying a message signal from the receiver to the from the transmitter to the receiver. So with by changing the parameters of the carrier signal. So basically, a carrier is something which is required for a message signal to be transferred from the transmitter and receiver if the distance is too large. So what are the advantage or why modulation is required? Signal optimization, bandwidth efficiency, noise resistance, multiple access, distance and coverage. So what is digital modulation technique? So digital modulation techniques involve varying a digital signal to encode information for the transmission over communication channels. These techniques convert digital data into an analog signal, making it suitable for transmission over various media such as radio waves, fiber, optics, or cables. So now we'll look into the different types of digital modulation techniques. And the first one is QAM, or which is quadration amplitude modulation. Quadration amplitude modulation is a digital modulation technique that combines both amplitude and phase modulation to encode information. It allows multiple bits of data to be transmitted simultaneously by varying the amplitude of two carrier waves, which are 90 degrees out of phase. Signal representation. In QAM, data is represented as a constellation of points on a two-dimensional plane, where each point corresponds to a unique combination of amplitude and phase. Multiple bits per symbol. QAM can transmit multiple bits with each symbol. For example, 16 QAM, 64 QAM, and 56 QAM. So basically, this is 2 to the power n. The applications are digital cable television, DSL broadband, Wi-Fi, cellular networks, orthogonal frequency division multiplexing, OFDM. So orthogonal frequency division multiplexing is a digital modulation technique that divides a single communication channel into multiple smaller subchannels, each carrying a portion of the data. The key features of OFDM include orthogonality, subcarrier transmission, robustness against interference, efficiency. So the subcarrier frequencies are mathematically orthogonal to each other, which means they can overlap without causing interference. This allows for efficient use of bandwidth. And robustness against interference means it is particularly effective in environments with multipath propagation, where signals arrive at the receiver at different times due to reflections. It can handle these delays without significant degradation in performance. By utilizing the available spectrum more effectively, OFDM can achieve higher data rates compared to the traditional single carrier modulation methods. Orthogonal frequency, or the OFDM, is widely used in various applications due to its efficiency and robustness. Here are some key applications: digital TV broadcasting, digital audio broadcasting, wireless local area networks, that is WLAN, cellular networks, and broadband DSL services. And phase shift keying. Phase shift keying is a digital modulation technique that conveys data by changing the phase of a carrier signal. The phase of the carrier wave is altered to represent digital information, allowing it to transmit data effectively over communication channels. Here's an overview of PSK and its variations along with their uses. Key features of PSK. Phase modulation. In PSK, the phase of the carrier signal is shifted to encode information. For instance, a signal might be shifted by 0 degree, 180 degree, or other specified angles to represent different data values. Types of PSK: BPSK, which is binary PSK, QPSK, which is quadric PSK, and 8 PSK, and differential PSK, DPSK. So we don't need to go through each and every variation of PSK in depth. So this is just a small summarized version of the types of PSK. You can just go through it if you want. These are the uses of PSK, which is wireless communication, satellite communication, digital TV and radio, modems, Wi-Fi networks, Bluetooth, and storage. So basically, one thing that we can conclude from this is that digital modulation is mostly used for, or I would say, completely used for digital devices like Bluetooth devices, mobile phones, televisions, and I think the quality or the pixeled images that you get on the TV, or the high quality of audio that you hear from your headphones or earphones, it's because of the accuracy of the digital signals or the digital modulation techniques. So this actually has a bigger hand or a upper hand over analog signals, and that's the reason digital modulation techniques are preferred than analog modulation techniques. That's it for this video. Thank you.